Okay, Chem, chapter 3, course revision. We have these questions included. 1 to 6, let's start. Yalla. Calculate H plus and OH minus in 0.01 LiOH. You write the dissociation of LiOH. I'll solve this fast. I won't actually calculate it. You can calculate it yourself. You can get Li plus and OH minus. Same coefficient. That means same concentration. So since you have 0.01 here, and it's also 0.01 here, that means concentration of OH is this. How would you find H plus? You do 10 to the power of minus 14 over concentration of OH minus. Okay. Yes, over here. Question 2. Consider the following. Which of the following can react with hydrochloric acid but not with sodium hydroxide? So, which can react with an acid and not a base? Which one can react with an acid only? It has to be a base, right? Because bases cannot react with bases. If it could react with both, it would be amphoteric, and we don't want that. We want only hydrochloric acid. Okay, so it has to be a base. Which ones are basic oxides? Calcium oxide and magnesium oxide. Okay, so CaO, MgO, because they're basic oxide. Can react with aqueous sodium hydroxide, but not with acid. So it can react with a base only and not an acid. Okay, which one? It has to be an acid, right? If it can only react with the base, that means it's an acid. Which one's an acid? SO2, SO2, and Al2O3. SO2, Al2O3. My bad. Al2O3 is not, it's amphoteric. I forgot. Anyway, shout out to Laith Nasser Saleh Alaouni for helping me with that one, come on. Again, thank you so much, Laith. So SO2 only, everything else, CO2 as well. Remember, the O2s are always acidic. So it's CO2 and SO2, not SO2 and Al2O3. Al2O3 is amphoteric. So if you want both, you're going to put the amphoteric one, which is Al2O3. And yeah, that's pretty much it. And obviously cannot react the neutral one, so it's going to be CO. So the acidic ones, I memorized it. It's every O2 plus B4O10. And the amphoteric, ZnOPBO Al2O3. Okay. Don't react these. Yalla. Fill in the table to identify if it's acidic, basic, neutral, or amphoteric. MgO basic, CO2 acidic, CuO basic, N2O neutral, CO neutral, ZnO amphoteric, SO2 acidic, Al2O3 acidic, Al2O3 amphoteric, COO basic. Okay. You know what? Take a look at the answers over here. Which of the following elements is most likely to form an acidic oxide in a non-metal? It has to be a non-metal, right? So it would be C. Why not D? Because D is a noble gas, right? These are metals. It has to be acidic, so yani it's non-metal. Which one's non-metal? C only. So it should be C. Yes. 3 methods are used for salt preparation. Oh, whoa, whoa! That's a lot of parts. 3 methods are used. Okay, method A using a Burton indicator. So let's start to label these. So titration. Yeah, we're gonna I'm gonna put it on the right, so I don't have to keep on going up. Okay. A is obviously titration because a Burton indicator. It's the titration method. You guys know this. Mixing 2 solutions to obtain a solid precipitation. That's the precipitation method. Okay, it's for insoluble salts. Thank you, late Nasser Saleh Alaouni, for mentioning this to me also. Addition of an excess base or excess metal. Obviously, this is the excess method. So this is base. So these are almost the same. Okay, yes, this is base slash metal. Base or metal plus acid. So D is excess metal oxide plus acid. And then E is excess metal carbonate plus acid. Okay, choose the method and name any reagent needed to complete the reactions. Let's see. We want the soluble salt, zinc sulfide, from the insoluble base, zinc oxide. Yeah, soluble salt. So are we going to use precipitation? No. Okay. Zinc sulfate from the insoluble base, zinc oxide. insoluble base. The base is insoluble. So are we gonna use titration? No. The only time you'd use titration is if the base is soluble. ماشي, easy peasy. يلا. So the method, we're gonna choose which one. We want to produce a salt from a metal oxide, right? So which one are we gonna use? Method D. صح, metal oxide. What do we have to add to zinc oxide to get zinc sulfate? You know, it's metal oxide plus acid. So we need to add an acid. So H something. Zinc oxide, zinc sulfate. Zinc with zinc. Oxide, we don't add it. You never add O. So what's it going to be? Sulfate. You guys know sulfate is SO4 2 minus, right? H plus SO4 2 minus. What compound do I have? Cross H2 SO4. So reagent is H2SO4. And you can say sulfuric acid. Word equation, I'm just going to show you this. This, it's going to be zinc oxide plus sulfuric acid to get zinc sulfate and water. Yes, you have to say why water. Remember, guys, remember these equations, all of them over here. Okay. Yeah, these equations here, this is what I'm talking about. Acid plus metal oxide gets you the salt plus water. Okay, so. Okay. Let me erase this and let's go to part B. The soluble salt, potassium chloride. So we want soluble, so it's not precipitation method. From the soluble base. Now, since we have a soluble base, what we can use? Titration, right? Since it's soluble base, titration. So I need the method is going to be titration, so method A. What reagent do we add? Potassium hydroxide, KOH. We need to add something for it to become potassium chloride. Let's see. It's a base, right? This is it's a metal hydroxide. What do we add to metal hydroxide? You're always adding an acid, right? It's acid plus metal hydroxide, acid plus this, acid plus this, acid plus this. Okay. Let's see. K with K. We're obviously not gonna add K. Do you add OH? No. We know it's an acid, right? We know it's an acid. You're always adding acid plus metal oxide, acid plus metal carbonate, acid plus metal sulfite, acid plus metal. It's always acid plus, right? This is my metal hydroxide. I need to add an acid, so it will be H something. H what? Cl. You need a Cl, so HCl. So the reagent, HCl. And the equation, they want the actual equation, not word equation. So what will it be? You just copy this down. KOH plus HCl to produce the salt KCl plus water. Okay, let's see. Balanced KK OH HH2O Cl. Yalla, balanced. Let's double check from the solution. A, KCl, Oh, put state symbols. Obviously, aqueous, because it's soluble, aqueous, because it's soluble, aqueous, again, because it's soluble, and liquid, right? Insoluble salt. Insoluble salt. What is the only method you can use for preparation of insoluble salts? The precipitation method is the only one, right? What's the precipitation method? B. So, B. Whoa. B. The reagent. What do you add to lead? What do you add to lead nitrate to get lead iodide? Let's see. PbNO3, right? We want to get lead iodide as my product. So plus something to get lead iodide. PbI2. PbNO3. There's a 2 here because it's lead 2. Okay. What do I add? I need something. Pb cancels Pb. And I need a salt. A salt that contains what? I, right? It should contain I. And remember, since it's the precipitation method, the salt has to be what? Soluble. Okay? The salt has to be soluble because precipitation method is the mixing of 2 soluble salts to get 1 insoluble. PbNO3 soluble because it has NO3. So we need to add something to I to make it soluble. You can add anything. I always prefer to add something from the big 5, like Na. Okay? NaI. So the reagent will be NaI. And the equation would be PbNO3. Remember, it's PbNO3 2 because it's lead 2 iodide. So Pb 2 plus, and then N3 minus, cross get PbNO3 2. PbNO3 2 plus NaI aqueous to produce PbI2, which is a solid, and then plus what's left? NaNO3, sodium nitrate. Okay, this is just the leftover, right? You have to complete it. So I want to see in the solution, do they want you to complete it? Oh no, did they say not ionic? They didn't say not ionic. They were supposed to specify not ionic. Uh, by the way, they said K. You can use K. Uh, you can. So listen, obviously, you're supposed to specify that it's not ionic equation. Here, they didn't say not ionic. Uh, so write it like this. I think why they want you to put not ionic again. Leif Nasser Alaouni, he helped me with this one. He told me because net ionic won't show the salts. It will just show, you're putting PB with I. Honestly, do what I did. Don't listen to what Leif Nasser Alaouni said. Uh, I prefer what I did. Okay, just add anything from the big five, preferably Na, because Na dissolves with everything. Okay. Name the chemical needed to be added to magnesium oxide to form magnesium sulfate. Okay, magnesium oxide, you need to add something to get magnesium sulfate. Magnesium oxide is a metal oxide. You're getting a salt, right? Always acid plus metal oxide to produce salt and water, right? طيب, we need to add an acid. What's my metal oxide? It's MgO2. Is Mg2O. Mg2O. No, MgO. It's just MgO. What am I saying? It's just MgO. Okay. And what are we getting? Magnesium sulfate, MgSO4. So we need to add an acid. What does an acid always have? H. Okay, Mg with Mg. What do we have? SO4. So can we write HSO4? No, it's HSO4. I don't want you to waste time to crisscross and whatever. Anytime the acid has SO4, just put please H2SO4. Okay. Which method can be used to prepare the soluble salt potassium chloride from potassium hydroxide? KOH. K is part of the big five. So that means the base I'm using is soluble. So what's the method that I'm going to use? Titration. And what's titration? Method A. Okay. Let me just double check with my answers. These sulfuric acid. Okay. That was the reagent. You have to, did they say name it? Yes, they said name it. So you have to say sulfuric acid. And then E, method A. Okay. Excellent. F, name the chemical needed to be added to lithium hydroxide to form lithium sulfate. Okay. Again, lithium hydroxide is your metal hydroxide, right? What do you add to metal hydroxide? You always add an acid to produce what? Lithium sulfate. So lithium sulfate, it's going to be Li2SO4. Okay, what do you add? My metal here is lithium hydroxide, right? I need to add an acid. Obviously, Li cancels with Li. The acid always has H, so I need to add SO4. And what do we just put HSO4? No, it's always H2SO4. Okay, so sulfuric acid. Okay, again sulfuric acid. I don't know why here they put it with pH and here with F يعني ما بفهم عليهم بس يلا. Where am I? Maybe because like Lake Nasser Alaouni said, in part D maybe the first one was answered by an English guy and the second one by an American guy. I don't know, but يلا. Okay, which method can be used to prepare part G? We did F. Yeah. Which method can be used to prepare the insoluble salt silver chloride from the soluble salt silver nitrate? Okay, insoluble salt, and we're gonna use which method? Precipitation method, so method B. Easy. Guys, this question is so easy, wallah. Name the chemical added to silver nitrate to form silver chloride. For your info, AgCl is insoluble. Okay? Name the chemical added to silver nitrate to form silver chloride. So what plus AgNO3 gets me AgCl? Okay, أكيد Ag cancels with Ag. We don't want NO3. We need something with Cl. And remember, since we're forming an insoluble salt, I need to use the precipitation method. Like part G, we said we're using method B, the precipitation method. What is the precipitation method? You mix two soluble salts. They both have to be soluble. HNO3 is soluble because it has NO3. So it has to be something with Cl that's soluble. What do I always tell you? I always tell you to add something from the big five because that guarantees it's always soluble. And the easiest thing is Na. So I just add NaCl. So let's see part H. Part H, we said method B, sodium chloride, NaCl. Yeah, they actually took NaCl. Fabulous. Part I, which method can be used to prepare the soluble salt magnesium sulfate from the insoluble base magnesium oxide. So now they said insoluble base, so we're not going to use method B. What you say, soluble salts, we're not going to use method B for precipitation because that preserves an insoluble salt. And we're not going to use method A, titration, because the base here is insoluble. What we're going to use, we're going to use one of the methods, one of the excess methods, right? What are we adding here? Where am I? Yeah. We're adding a magnesium oxide, right? So which one are we going to use? We're going to take the excess metal oxide. So part D, method D. Yeah. J. Which name the chemical need to add insoluble to be added to insoluble calcium oxide to form calcium nitrate? Okay. Calcium oxide is CaO. CaO. CaO, yeah. Plus something to produce calcium nitrate. CaNO3. 2. No, wait. Yeah. This is a metal oxide, right? Metal oxide plus what gets me salt? Always acid plus metal oxide, right? So which method are we going to use? We're going to move method D. But what are they saying? They want the chemical. Ca cancels with Ca. And since I need an acid, it's going to be H. What am I using here? What am I getting? NO3. So HNO3. And what is this acid called, guys? Nitric acid. Okay, so J, it should be nitric acid. Yes. K, which method can be used to prepare the soluble salt sodium iodide from sodium hydroxide? Sodium hydroxide, be careful, is a base. And is it soluble? Yes, because it contains sodium. NaOH, guys, is soluble. So which method are we going to use? Titration. So we're going to use method A. Method A. Yeah. Name the chemical needed to be added to sodium hydroxide to form sodium chloride. Something to be added to sodium hydroxide to form sodium chloride. So to form NaCl, we need to add something to NaOH, sodium hydroxide, right? We need to add something plus metal hydroxide. What do we always add to metal hydroxide to get a salt? Acid, right? What's the acid? It's always H something. Let's see. Na cancels with Na. So what do we have left? Cl. Okay, HCl. What is it called? They're saying name, huh? Not give the chemical formula. They're saying name. Be careful to the questions. So I feel bad for those people. Yani, they get these mistakes just because they didn't see. They said name, but they know it. And please don't say hydrogen chloride, guys. Don't, please. This is such a stupid mistake. Don't say hydrogen chloride, guys. It's hydrochloric acid. HCl is called hydrochloric acid. Which method can be used to prepare the insoluble salt lead iodide from the soluble salt lead nitrate? Okay, again, we're saying insoluble salt. So which method is going to be the precipitation method? Method B, right? Name the chemical added to lead nitrate to form lead iodide. Now you want a chemical. We need to add something to PbNO3 to form lead iodide. I feel like we solved this before. I don't know. Anyway, Pb cancels with Pb. We need I in it, right? We always need I. And we need to add something here. Again, we're saying we're using method B, and method B is the precipitation method, which involves the mixing of what? They have to be both soluble salts. Soluble salts. So it has to be soluble. So how do I ensure it's soluble? I just add anything from the big five. So Na. Okay? So sodium iodide, NaI. Okay, that's question 5. No. Question 6. Acid-base titration until this is okay. This is the last question. I skipped some. Okay, if the burette was filled with dilute hydrochloric acid and the solution was slowly added to a conical flask containing dilute sodium hydroxide solution, what will be the color change if the conical flask, if the following indicators are added? Litmus indicator is used. A burette was filled with acid and they kept on adding base. So it started as an acid. So it starts as red. It finishes as a base. So it finishes at blue. Methyl orange. Methyl orange, upon being in contact with a neutral solution, it's yellow. And then when it becomes a base, it's red. Thymolphthalein is colorless and becomes blue. I think. Blue to colorless. Oh, why is it the other way around? Oh, they said the burette has hydrochloric. Okay. Okay, the conical flask had the base. Okay. So it was changing from base to acid. So yes, swap these all. Ya Allah. Okay. So blue, red, and then methyl orange is red to yellow. And the phenolphthalein is blue two colors. Okay, so oh my god, oh my god, oh my god, I forgot. Methyl orange is orange when it's neutral, and then yellow. Oh, so it's acidic because it's yeah stronger concentration. Okay, yeah. My fault, okay. So it's yellow to red. Okay. So we're supposed to skip question 7. 8 here. 200 ml of NaOH is added 200 ml of HCl. Calculate the final concentration of H and OH. If you get this in computer, since they both have same volume, same concentration, you can immediately know that the solution is neutral and that in a neutral solution, concentration of OH minus is equal to concentration of H plus, which is equal to 10 to the power minus 7 more. You can memorize this, but look, it's a bit written. Obviously, you're not allowed to say this. You have to like show them, the moles of NaOH, or sorry, the moles of OH. Sorry, and we're comparing H plus and OH. Of H plus is equal to the moles of OH minus. Then there's no excess. That means solution is neutral. That means concentration of H plus is equal to concentration of OH minus is equal to 10 to the power of minus 7. But we have to show this. How do we show this? N is equal to CV, right? So N of H plus is equal to, where am I? HCl. Do you know dissociates to get Cl minus and H plus? Since they have the same coefficients, so same number of concentration. So CV, so the concentration, N is equal to CV, concentration is 1, times the volume is 200. Let's just keep it in terms of millimole. I don't want to divide. Because when you're comparing, if you're using both of them milli, it doesn't matter. And then N of OH, sorry, 200. Why didn't I write? I just put 200 millimole. N of OH minus is equal to the concentration of OH. It's NaOH. Dissociate to get Na plus and OH minus. Same constant, same coefficient. So that means if you 200 pump them, then it's gonna be the same coefficient here. NaOH and OH minus have the same concentration. So the concentration of OH minus is gonna be 1 here. Volume is 200. So you're gonna get 200 millimole over here. So since they have the same number, since they both have the same concentrate as the moles, that means you write this. That means you write there's no excess one. That means the solution is neutral. That means you get this. Okay. 9. Calculate the H plus. Oh my god. I'm just gonna show you the solution. Okay. HCl dissociated. You get what? H plus and Cl minus. Yeah. And so they have the same. Oh my god. You know what? I'm just gonna write, but I'm not gonna explain. عشان ما نخرب. Okay. Okay. Same coefficient. يعني you get 0.01, 0.01. Then to find OH, you do 10 to the power minus 14 divided by this, right? And at this point, if you're doing course division, everybody should know these questions. Calculate the H plus and OH minus in 0.4 grams of NaOH dissolved in 10 centimeter cube. Okay, NaOH gets you Na plus and OH minus, right? Same coefficient, same concentration. What's the concentration of NaOH? It's N over V. But I need my moles first, right? N is equal to the mass divided by the molar mass. The 16, 23, 40. The molar mass of NaOH, if we have periodic table, it's going to be 40. Anyway, so the molar mass is 40. The mass is 0.4 grams. Remember, in chem, we don't use kilograms, we use grams. So 0.4 divided by 40. So you get 0.01. C is equal to N over V, so 0.01. Over the volume 10 centimeter cube. 10 centimeter cube has to be liters or decimeter cube, right? So you have to divide by 1000. It's also 0.01. So it's going to be 1. So concentration is 1 molar. So the concentration of NaOH is 1. So the concentration of OH is 1. So how much to get now the concentration of, this is OH minus, to get H plus, you have to do 10 minus 14 divided by 1, and you get 10 minus 14 for H plus. If the pH of solution is 5, what is the H plus? You know that the concentration of H plus is equal to 10 to the power of negative pH, so 10 to the power of negative 5. Is the solution acidic or basic? If the pH is less than 7, then it's gonna be acidic. 12. We have 12. 12. Question 12. Classify the following solution as acidic, basic, or neutral. It's very easy. Obviously, pH 5 is acidic, pH 8 is basic, pH 7 is neutral. Write the action between HCl and water. Acid in water. What happens? It dissociates. So basically, you don't write plus H2O normally. You just get H plus and Cl minus. Aqueous, aqueous, aqueous. HNO3 and water, same exact thing. You dissociate it. H plus and O3 minus. Aqueous, aqueous, aqueous. H2SO4 and water show both steps of dissociation. H2SO4 dissociated the first time. Remember, you can only dissociate one H at a time. So you get H plus and HSO4 minus. Memorize this. Because, SO4 2 minus, it's SO4 is 2 minus. But if you add an H plus to it, 1 and plus negative 2 is negative 1. That's why the charge of HSO4 is minus. Then you take this HSO4 and you take the last hydrogen out of it. And you're going to get SO4 2 minus. But they're all aqueous here, by the way. But here, the last one is going to be a partial dissociation. Why? Because HSO4 is a weak acid. And for that reason, we classify H2SO4 as a partial dissociation. Okay? These are both steps of dissociation. CH3COOH and water, this is a weak acid, so it has to partially dissociate. So CH3COOH partially dissociates to get CH3COO minus and H plus. These are all aqueous, for now. H3PO4 and water show 3 steps of dissociation. H3PO4 dissociate. Is it weak? Wait, I need to check this though. Yeah, it's weak. It's weak, yes. HPO4 is weak, so the first, they will all be double arrowed, okay? HPO4, take one H plus out, what are you going to be left with? H2PO4 minus. Aqueous, aqueous. Then H2PO4, take one H plus out, you're going to be left with HPO4 2 minus. And then, last one, HPO4, to get H plus and HPO3, as you know, PO3. Ya Allah, take an H out, you're gonna be left with PO4 3 minus. Let me just double check this. They're all aqueous, huh? Yeah, you have to write the signs here. 2 minus minus. Yeah, they're all aqueous, huh? Here كان لازم يكتب aqueous. Okay. Where are more than one proton may be released? In which step is the acid strongest weakest? More than one proton may be released, obviously, in the ones where it's more than one hydrogen, right? Like H2SO4, H2PO4. So like C and E. And I didn't answer that for some reason. And which step is the acid strongest or weakest? Obviously, the acid strongest in HCl and is the weakest in H2PO4 because it has 3 dissociations. Okay, the more dissociations an acid has, the less its strength is. Okay. Complete these following equations. Okay, whenever you're reacting it with water, if it was directly an acid, it dissociates like over here, right? But here they are not directly acids. These are all oxides. When you add an oxide to water, it changes either into an acid or base depending on what it is. Here it's a basic oxide. So what's it gonna change into? CaOH. After that, you write its dissociation. Okay, so when you're adding an oxide to water, you write its change it into a base or an acid, then dissociate. Now dissociate CaOH2, you get Ca2 plus aqueous and OH, 2OH minus aqueous. I'm not going to write state symbols, but no, they're all aqueous. Okay, for now, I'm ماليش خلق. SO3 plus H2O. What acid do you get when you add SO3? What's H2? SO4, right? And then write the state symbol. Okay, and then do they write 2 dissociations or do they write it 1 complete one? Yeah, they write. Okay. Here, H2SO4, if you were to write it as 1 complete dissociation, you write it as a double arrow. Because remember in the previous part, when you go back, you'll see that the second dissociation of H2SO4 was double arrow. It was a partial dissociation. So even if you're writing complete dissociation, even though one of them was strong, one of them and the other was weak, you have to write, if it's all, referring to it all, you have to write double arrow. Okay, so you're going to get H plus, 2H plus, and SO4, 2 minus aqueous. CO2 plus H2O. Change it to an acid. What's the acid? It's H2CO3. H2CO3 it's a weak acid. I think, yeah, it's a weak acid. So you're gonna get 2H plus, double R 2H plus, and CO3 2 minus. SO2 plus H2O. Here we added one oxygen, became SO4. Here, if you add one oxygen, it's gonna become SO3. So the acid is H2SO3. H2SO3. Dissociate H2SO3. Again, it's weak, huh? It's very weak because all of the twos, they're partial dissociations. You're gonna get 2H plus and SO3 2 minus. K2O plus H2O, you're gonna get KOH, right? This is a basic oxide. You're gonna get KOH. And the dissociated, this should be strong. It's strong, right? So it'll be a single arrow. Yeah, single arrow. Yeah, it's single arrow. So it's gonna be K plus and OH minus. Na2O, H2O, again, it's a basic oxide, so it's gonna become a base, NaOH. It's strong, it will become Na plus and OH minus. All of them aqueous, huh? But I don't want to write them for you because I'm lazy. Okay. Write down the complete acid base equations of the following. Neutralization of an acid in a base. كيف يعني? Acid in a base gets you salt plus water. Yeah. Okay. Okay, yeah. Acid plus base gets you salt plus water. Carbonate ion in water. What happens? Ah.
Yes, correct.
Basically, carbonate ion plus water. Memorize these all, okay? Carbonate ion, when you put it in water, it becomes H2 CO3. And since it's in water, it's going to dissociate to get H plus and HCO3. This was in the book. Okay, so here it is. Just memorize it. Okay. Sodium carbonate with a strong acid. Okay, sodium carbonate with a strong acid. Metal carbonate with an acid. This one we know it, right? Metal carbonate with acid. They just want the net ionic. What is it? Metal carbonate plus acid gets you salt, water, and carbon dioxide gas. The net ionic, I'm gonna make your life way easier. Sodium carbonate. Wait, before I go here, it's actually OH, because in this case. So look here, CO3 2 minus. It was in the quiz, guys. CO3 2 minus is a weak base because it's negative. A base is anything that is a proton acceptor. Okay, so here it's gonna be a base, so it's gonna be OH minus and HCO3. Okay, not H plus. Ammonium ion in where am I? No, see. So they want the net ionic. Okay, for the net ionic of metal carbonate plus acid, it's always gonna be H plus CO3 2 minus to produce CO2 gas and H2O liquid. This is the net ionic. You can memorize it. Unless this is for the case that both the reagents are aqueous. Unless they say it's solid, then you have to use the method we did where you write the whole equation and see which one changed states. You can use that. But here, just for this question, you can memorize it easy. Okay, see, this is, you have to balance, of course. Yes. Okay. Ammonium ion in water. Ammonium ion in water. Okay, you know what? I'm gonna let you memorize this one. Memorize it. Ammonium ion in water gets you ammonia. Ammonia is easy, right? This is the easy part, right? And then you get hydronium. This is what we call hydronium, H3O. So just memorize it, guys. Just memorize it. H3O plus is when you get, and when you put NH4 ammonium ion in water. Just memorize it. Strong base and ammonium salt. Ammonium salt acts as an acid. Or actually, no. I'm not gonna even tell you this. Remember when we had base plus ammonium salt? What do you get? You get salt plus NH3 gas plus water, right? So you get. They want net ionic? Yeah, the net ionic would just be, yeah, of course. If they ask for net ionic, but this would be the normal equation. But net ionic would always be the base. What do we take from the base? Always the OH minus. From the ammonium salt, we're taking the NH4 plus to get ammonia gas, right? And water. This is if it was the net ionic. Okay? Memorize. Don't memorize. Like, I try and understand. Like, you're cooked. Just memorize. Honestly, just memorize. Yeah, it's all these seven. Okay, all these seven in addition to carbonate ion in water and sodium. No, not this, and ammonium ion in water. These two, memorize them. Okay. CaO plus 2H plus. Okay, this is metal oxide plus an acid. So basic oxide plus an acid. What you get? You get salt plus water. So what's the salt gonna be in this case? It's gonna be CaO. They just want Sheklo, they want net ionic for this one again because they didn't give you the other solid because you can't figure out what the salt is. So you know that the salt would be aqueous and water would be liquid, right? طيب, calcium is obviously going to take part in the salt. It was solid, it became aqueous. So I'm going to include calcium in my net ionic. I'm actually explaining this one. طيب, what else? The H was aqueous, it turned into water, which is a liquid, right? So you're going to put your H plus here. And obviously in our products we're not gonna put the salt, we're just gonna put that Ca turned into Ca2 plus, oh no, Ca solid. Ca solid. Okay. Why can't I say Ca2 plus salt? Because Ca2 plus is not a salt, it's an ion. Okay, so produces salt plus water. And my solid is Ca. It's a salt. I'm gonna cry. يا أخي. Other way around, guys. Other way around. I'm about to. Ya Allah. It should be here solid, here aqueous, because here it was solid in the reactants and the product became aqueous. So I switched them up. Just let me make sure of this. Yeah, never mind, guys. Never mind. The solution is different. Yeah, let me just scratch all of this. Let me just scratch all of this. Okay. Okay. It's to produce a salt plus water. Okay, the salt is aqueous, the water is liquid. Okay. Look at this. CaO. Ca, obviously we're gonna include it. But O, I forgot to include O because O is part of water. Water is H2O. Forgot to include that. It was a solid, became a liquid. So akid, I'm gonna include both Ca and O in my net ionic. So CaO plus H plus, because H plus turned into a liquid. It was aqueous, turned into liquid. So ID solid. It was solid. This one's aqueous. To produce what? Salt. Ca took place in the salt, so it's gonna turn into aqueous. Right? طيب. The water, you just write it as H2O. That's it. This one's a bit confusing, but these ones I just suggest you to memorize them, okay? But try and understand metal oxide plus acid gets you salt and water. Then the net ionic would just be this. Okay? SO3 plus NaOH. This is acidic oxide or metal oxide. No, this is not. This is base metal hydroxide plus acid. Yeah, guys, honestly, just memorize, wallah. Yeah, honestly, you guys are cooked. We're all failing tomorrow. Just memorize this. Actually, look here. I actually found the explanation. Okay, SO3, you're dissolving it, right? And we remember when we said SO3 in water, you get H2SO4, right?
Okay. And what?
So this SO3 can turn into H2SO4, and when you add the H2SO4 to NaOH, you get acid plus base. You get salt plus water. So you're gonna get Na2SO4 plus H2O liquid. This is aqueous. This is liquid. This was gas, no? Yeah. So here, if you want to write the net ionic, it was, you don't take the state here, you take the original one. It was a gas, right? So SO3 turn into SO4. So actually you're gonna put SO3 gas. And what else changed? NaOH. The OH here, it was aqueous, right? It turned into water. So we're gonna include the OH minus aqueous. To produce SO3 was a gas. It turned into SO4 aqueous. What's SO4 aqueous? It's SO4 2 minus plus water H2O liquid. Yeah, I don't know. This is it. Is this it? Okay, balance. Oh my god. Oh my god, I actually solved it. I didn't expect I'd get this right. But yalla. ما بدي اخلص والله. how many do I have left? Oh my god. Calculate the H plus and OH minus in the solution. Oh, استغفر. Okay, pH. H plus. So, concentration of H plus when you have the pH is 10 to the power of negative pH, so 10 to the power of negative 5. Then OH, how do you get in 10 to the power negative 14 divided by H plus 10 to the power negative. I'm just going to show you the solution. 18. Look. Okay, just look, you get this is 10 to the power negative 5 because H plus is always 10 to the power negative pH, okay? And then you do 10 negative 14 over that, you get this. Okay, then here, it's going to be H plus is going to be 10 to the power minus pH, minus 8. And then 10 to the power minus 14 divided by minus 8, you get this. And then pH 7, they're always equal to each other, minus 7, minus 7. Okay, are the both solution acidic, basic, or okay, guys, into, I'm sorry, but I'm going to skip this, okay? Solution of, you know what, no. 7 is neutral, above 7 is basic, below 7 is acidic. A solution of concentration acid is added to an aqueous solution of sodium carbonate. What is the expected observation? Metal carbonate plus acid. Acid plus metal carbonate. What do you get? You get salt plus CO2 plus water. So what's the observation? Since you're producing a gas, effervescence. Give the net ionic equation. Always the net ionic is just going to be H plus CO3 2 minus to produce CO2 gas and H2O liquid. This is just memorize it. أنا خلاص I memorized it. I stopped understanding it. I just memorized it. It's way easier, okay? Let me just check the solution عشان ما بكون عم خبص. 20 صح؟ okay. Balance. Okay. What is the oh my god. What's the OH in pH 8? pH 8 يعني H plus is 10 to the power of negative pH 10 to the power of negative 8. How much should OH be? 10 to the power of negative 14 divided by 10 to the power of negative 8, so you can get 10 to the power of minus 6. 22. And oxide X. Oh, these are tops. Oh. 20, 24, 26, 38. Is 26 to 38 multiple? Oh my god. Okay, we can actually finish. How long is this? 42. Okay, we can put it under 55 minutes. Yeah, I'm joking, guys. It's not gonna be under 55 minutes. Okay, and oxide X reacts with both potassium hydroxide and sulfuric acid. What is true about X? So it reacts with a base and then acid. So what is it? It's amphoteric. Oh my god. Question 23. Okay, this question was in the notes, by the way. A student titrates an aqueous sulfuric acid solution using 25 centimeter cube of 0.05 molar solution. These are wrong, but this should be here. This should be here. Okay, this should be swapped. Okay, if something's being titrated, then it should be down. Okay. Okay. Whatever. Okay. So this one, honestly, in my opinion, you're gonna get this tomorrow in your written. Okay, in my opinion. But let's solve. Let's solve وناكل خلاص. Okay. What is the concentration of sulfuric acid solution? First thing, calculate the number of moles of calcium hydroxide. Calcium hydroxide. Where's calcium hydroxide? They gave us the volume and they gave us the concentration. How do you find moles? CV. Okay, calculate the number of moles and equal to CV. The volume has to be in liters, so you're going to be 0.025. So how is it going to be? It's going to be 0.025 times 0.05. Okay, so sodium hydroxide, the calcium hydroxide, 0.025 times 0.05, you're going to get 1.25. You're going to get this. Wait, no. You're going to get this. Okay, let's check our solution. You're going to get this. Okay, calculate the number of moles of sulfuric acid to react completely with calcium hydroxide. Here, they're saying you want how many moles reacts completely with calcium hydroxide. أول شيء you need to say N over coefficient of the acid is equal to N over coefficient of the base. Okay, I didn't write this in the solution, but I'm telling you, you have to write this. Okay, N over coefficient of the acid. The acid is H2SO4. Okay, you can write this on the side. H2SO4 CaOH2. When you add them, they're already balanced since they both have the same a number of H's. So you're gonna say same coefficient. Okay, so that means you don't put it over any coefficient. So that means you're gonna write this first, then you're gonna write this second, then you're gonna write this third, and then you're gonna say that means n of the acid is equal to n over the base. That means you're gonna get, we said 1.25 times 10 to the minus 3 is equal to the moles of the acid, sulfuric acid. Okay, is that the solution? Yes. Okay, calculate the concentration of the sulfuric acid solution. Concentration is equal to n over v. The moles is 1.25 times 10 to the minus 3, and the volume of the sulfuric acid solution is 12.5 centimeter cube. We have to make it into dm cube or liter. Divide by 1000, so it's going to be 0.0125. Okay, divide by 0.0125, and when you divide, you should get 0.1. Okay. For part B, now, after titration is done, the final solution in the beaker contains solid calcium sulfate, water, and some dissolved acid-base indicator. Describe how to extract a dry sample of solid calcium sulfate from the solution. Write the process including all key steps. Okay, you have solid calcium sulfate. How do you remove a solid from a solution? You just filter it, right? So you should perform a filtration. Okay, and then after you filter it, you get CaSO4, and then you have to rinse it. Once you filter it, you have to rinse it with water to wash off any like unwanted stuff. Okay, so you have to rinse it with water, distilled water. You have to say water, distilled water, whatever. And then obviously we need to dry it. So you place it between two filter papers and gently press to dry. Or you can say place it in an oven. You choose what you want, but these steps must be memorized. Okay, so before filtration, get solid CaSO4, and then rinse it with water, distilled water, and then place it between two filter papers and gently press to dry. Okay, and then he said if the titration product is a soluble salt, then what do? You have to use crystallization, right? Evaporate heat until more. Okay, and then allow cooling to crystallize. This is for crystallization. I mentioned it in the notes, inside in the quiz. You should know it. Okay. The student conducting the following test. That's if it was soluble. See, we don't need crystallization. The student conducted the following test on the products of the reaction between sulfuric acid and sodium carbonate. Describe the student's observation each test. The flame test. Now, what do we get? We got CaSO4. Okay, calcium in the flame test. What did it give you? Brick red flame, right? It's not the same. See, they're trying to trick you here. Okay. See, they're trying to trick you here. They're putting a different reaction. In the question, it was calcium hydroxide. Here, it's sulfuric acid and sodium carbonate. Sulfuric acid and sodium carbonate. It's an acid plus a carbonate. What does an acid plus carbonate get you? Salt plus carbon dioxide gas plus water. Okay, let's see. The salt produced sulfuric acid and sodium carbonate, H2SO4, and sodium carbonate, Na2CO3. Box up the middle. What do you get? The salt produced is Na2SO4. If you do a flame test on A, what do you get? Yellow flame. The gas released in lime water. What's the gas? CO2. In lime water turns lime water milky. I'm not gonna continue. Addition of an aqueous solution of barium nitrate. Barium nitrate. When you add barium to Na2SO4, the barium will react with the SO4. Remember, the test for SO4 is adding barium nitrate, and you're going to get a white precipitate that does not dissolve in water, right? So when you add B8 nitrate, you're going to get white precipitate that does not dissolve in water. Or just say white precipitate. Okay, dilute. Dilute, pardon. Sulfuric acid reacts with metals, metal oxides, and bases. Write chemical equations for the reaction of dilute sulfuric acid, each of the following. Magnesium. You react acid plus metal. What do you get? Salt plus hydrogen gas, right? In other words, what's the salt produced? Sulfuric acid, H2SO4 plus Mg. What do you get? We need to write the actual equation. You're gonna get metal. What's the metal? You box up the middle, you're gonna get Mg. Sorry, the salt produced. Why am I saying that? You're gonna get Mg you're gonna get MgSO4. Because if you crisscross, by the way, it's SO4 2 minus, Mg2 plus. crisscross, they cancel out, you can get MgSO4. Okay, which is aqueous, obviously, and plus hydrogen gas, always. This is the reaction between a metal. Sodium oxide. When you react acid plus metal oxide, what do you get? You're gonna get salt plus water. So let's add sulfuric acid H2SO4 to sodium oxide NaO. What do you get? Box of the middle, you get NaSO4, Na2SO4. Because remember, Na is Na plus, SO4 is 2 minus. Crisscross, you get Na2SO4, which is obviously aqueous, plus water, which is a liquid. Potassium hydroxide. KOH. Metal plus hydroxide gets you the same. Acid plus metal hydroxide, sorry, gets you the same product. Okay. What we're doing? We're doing H2SO4. We're adding it to our metal hydroxide. It's gonna be potassium hydroxide. So what's it gonna be? Box of the middle, you're gonna get K2SO4, right? Because SO4 2 minus K plus crisscross. You're gonna get, it's obviously aqueous, plus water, H2O, liquid. See, these are the chill parts. Like, oh, come on, you have to balance. Yeah, okay, yeah, balance. Wow. Here, Na2O. Okay. Yeah, don't make the mistake here. It's not NaO. We never have NaO. We have Na2O. Because, by the way, Na is Na plus, O is 2 minus, so you're gonna get Na2O. Okay. Let's see. Question 24. A sodium. Oh, okay. A sodium. شو a sodium? A student. أنا how many questions? 2024. A student conducts an acid-base titration to determine the concentration. He is provided with a following apparatus. Name the items that the student needs to perform the titration. Okay, I think. Yeah, I think. Are you supposed to name all 5? No, you don't. So basically, they gave you these, and you're supposed to choose. Obviously, you don't use a volumetric flask. You don't use this. I'm sorry, measuring cylinders. You don't use a measuring cylinder because it's inaccurate. Now we use a conical flask, or what they call Erlenmeyer flask in the quiz. And then D is the burette and E is the pipette. You need these. We don't need this. So what's this? Conical flask. Yeah. The student adds few drops of an acid base indicator to 20 centimeter cube of hydroxide, sodium hydroxide, and titrates a mixture with a hydrochloric acid solution. Why is it necessary to add an acid base indicator before starting the titration? Because why? Because you want to see the change in color, no? Indicates the endpoint by changing the color. Yeah. Okay. The student makes 2 readings to determine the volume of the hydrochloric acid needed. The initial reading he made was 10 centimeter cube, and the final reading was 23. What does the volume of hydrochloric acid need to completely neutralize 20 centimeter cube? So, his final reading was 23, his initial was 10. Please don't do 10 minus 23 and get negative 13 and then just say, oh, volume can't be negative, so you get 13. No. That's stupid. Don't do this. Always final minus initial. Okay? So you're gonna get 23 minus 10, which is 13. Okay? You always do final reading minus initial reading. Yeah. Alright. Part C. The student repeats the same experiment using the same materials. He discards the content of the final solution from the flask and refills it directly with another 20 centimeter cube of the same sodium hydroxide. What did the student do wrong in this procedure? Describe obviously contamination, right? Yeah, he didn't clean the flask, okay? Now, people who take biology, whether it's year 2 or AS bio, know about contamination. And basically, contamination is when you're in the lab, and you're going to do this a lot next year. When you're switching out things, when you're switching out the contents of things, you have to rinse whatever flask you're using, whether it's tweezers you're using or test tube holders, you must rinse them. Okay? Like, don't be like Laith Nasser Alauni when he was in AS bio lab. He was using the same syringe for all 5 beakers of solutions. Don't be like that, okay? You should know that you must clean and rinse your solutions to prevent contamination, okay? Because it will give you inaccurate results. Okay. I know he should have rinsed the flask. Okay. With distilled water. Okay, which of the following reagents can be added to hydrochloric acid to prepare zinc chloride? Acid plus something gets me salt. Let's see here. This remember this came. This is a salt. We need to add something to HCl to get zinc chloride. Obviously, the Cl cancels Cl. We need something with zinc. Okay. Acid plus what gets me salt? Acid plus metal. Acid plus metal oxide. Acid plus metal carbonate. I don't think it's D though. I think it's just ABC, right? Yeah, it's not D. It's not metal sulfate, but it's metal sulfide. If they said sulfide, then it would be correct. Sulfide is just S, no SO4, just S. Okay, so if you remember these, all of these, okay? Which of the following reagents can be added to sulfuric acid to prepare copper sulfate? So, sulfate with sulfate, so obviously we need something with copper, okay? Acid plus metal would be correct, so people would choose this. But we have an exception for the acid plus metal. Cu and Ag cannot be alone, okay? So, Cu is wrong, but metal oxide, metal carbonate, metal hydroxide, all correct. So again, this one should be BCD, right? Yes. Which of the following reactions produce ammonia gas? Acid plus base, no, this gives me salt and water. Ammonium salt plus base, yes, this gives me salt plus ammonia gas plus water. Acid plus metal carbonate, no, this gives me carbon dioxide gas plus salt plus water. Acid plus metal gives me salt plus hydrogen gas. Acid plus metal sulfide gets me gets a salt plus hydrogen sulfide. It's here. Acid plus metal sulfide gets me salt plus hydrogen sulfide. Which of the following reactions produces a pungent smelling gas that turns down petals with paper blue? Obviously, this one here, the answer was B, right? Because we wanted ammonia. Here they want ammonia. Which one give me ammonia? Obviously not this. Obviously not this. Obviously not this. Yani, okay, this is base. This is metal oxide plus acid. Obviously not. The only thing that can get me ammonia gas is when you have ammonium. Which is the only reaction? It's this one. Ammonium salt plus base. So we need ammonium salt plus base. So it's gonna be this one. Ammonium salt. يا أخي أصلا يا أخي, you want ammonia, NH3. Okay. How are you gonna get NH3 if you don't have any nitrogens in here? Tell me. يا أخي, you can't. So obviously it's gonna be D. Okay. Okay. Question 30. Which of the following reactions would produce a gas? Okay. Acid plus gas. Acid plus base gets me salt plus water. So no gas. Ammonium salt plus base gets me NH3 gas, right? Acid plus metal carbonate, carbon dioxide gas. Acid plus metal gets me hydrogen gas. Acid plus metal sulfide gets me SO2 gas. Acid plus metal oxide gets me water, only doesn't. Okay, so it's gonna be these B, C, D, E. Right, yeah. And they are actually over here. All of these reactions. The only one that get me gas is number 1, number 4, number 5. I should have written gas here. Number 1, number 4, number 5, and number 7. The reaction of a strong acid with a strong base to produce salt and water. What do we call this? Acid plus base is always called neutralization reaction. During the preparation of silver iodide, AgI, by precipitation, what is the correct order of the steps? أول شيء, we mix both aqueous solutions, right? Then we stir them with a glass rod. Then you filter and dry. So it should be ACBD, right? ACBD. أول شيء, you mix both aqueous solutions with a glass rod. So this is 1, this is 2. Then you get a solid precipitate. So you need to filter it out, right? And then after you filter it, there's still going to be some liquid particles on, so you have to dry it. The pieces of apparatus needed during the preparation of sodium chloride by NaCl are what? Obviously, it's going to be C, okay? This comes every exam. During the titration of an acid with a base, the color that changes when phenolphthalein is used as an indicator. Titration of an acid with a base. When we say titration of an acid, that means the acid is down. The thing being titrated is the thing that's down. Okay? So it's changing from acidic to basic. Acidic phenolphthalein is colorless. And basic phenolphthalein is pink. Titration of acid with base. We need methyl orange. Acid is red. Base with methyl orange is going to be yellow. So let me see 34. First pink, red to yellow. Dilute sulfuric acid is added to a mixture that contains magnesium, zinc, and copper in a beaker. So acid is added to magnesium, zinc, and copper. The beaker is left for about 15 minutes and its contents are then filtered. What does the filtrate contain? Okay, when we say what does the filtrate contain, it's basically you put these together and then they got filtered. So basically what actually dissolved? What reacted with it and dissolved? Then we know magnesium, acid plus metal. We know acids react with metals to get me a salt and hydrogen gas, and that salt is dissolved in water, so it's going to go down. However, we know that the only exception to this, there are 2 exceptions to this rule, and it's copper and silver. So that means my filtrate, when I filter it, the copper is still gonna stay as solid here. It's not gonna react with the sulfuric acid, so it's gonna be everything except copper. So it's gonna be magnesium and zinc. Are we done here? Two more questions. Okay. Some reactions are shown. There's no question. Wash, 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 wash. Okay. Uh, I think they're asking you what substance M يعني. Okay. Substance M reacts with a metal to produce hydrogen. So أكيد it's an acid. And also reacts with a carbonate to form carbon dioxide. أكيد it's an acid. And reacts with copper oxide to form metal oxide to form a salt. So أكيد it's an acid. I think they're asking you what is the acid? What is the acid? You're supposed to see when it reacts with a copper oxide, it produces the salt copper chloride. That means my acid contains Cl. Which acid contains Cl? You always add an H, so HCl. Okay, let me see. Is the answer hydrogen chloride? Yeah, hydrochloric acid. Hydrochloric acid. You need to name it. Okay, you need to name it. What is substance M called? You have to say hydrochloric acid, not hydrogen chloride. Hydrochloric acid. The information is about the preparation of magnesium nitrate, MgNO3. Okay, add spatula measures of. Oh my God, why is it? Okay, to some hot dilute nitrochloric acid. Add spatula measures of magnesium oxide to some hot dilute nitric acid and then stir. Okay. Continue adding magnesium oxide until it is in excess. Okay. Remove excess magnesium oxide so that colorless magnesium nitrate is left behind. Okay. Evaporate the magnesium nitrate solution until saturated. Leave the saturated solution to cool. White crystals are seen on cooling. Remove the crystals from the solution. Dry the crystal on filter. Explain why excess magnesium oxide is used in step 2. Let me explain what's happening here. We're adding magnesium oxide. We're adding a metal oxide to an acid. You know, when you add metal oxide to an acid, you get salt and water. Okay, easy. طيب. For this method, this is the excess method, right? So we use excess. Why do we use excess? So that you can ensure it fully reacted, right? So that all the acid is used up. So it all reacts. So all the acid is reacting. Okay. So all the acid gets reacted. So it is all used up. Whatever. Well, use the answer that's written here so that all the acid is used up. Anytime you're using excess, that means you want it to fully react. So all the acid is used up. Explain how the magnesium oxide is removed from solution in step 3. طيب. In the excess method, we get an aqueous salt. So how would you remove it? So it's gonna be the salt will be aqueous, but the leftover excess it's gonna be solid. The leftover we're leaving over. Remove excess magnesium oxide. Magnesium oxide is solid. Magnesium nitrate is the salt we just produced. It's aqueous, right? How do you remove the excess solid? We filter, right? So we're gonna use filtration. What is meant by the term saturated solution? That which no more can dissolve, right? A saturated solution is in which no more solid or solute can dissolve at that temperature. You have to say at that specific temperature. Okay. What is the practical method that will show that the solution is saturated? Dip a cold glass rod in it. I'm sure a question like this will come. Okay. Dip a cold glass rod to check the formation of crystals. If crystals form, yani it's saturated. Okay. Explain why the crystals in step 7 are dried using filter paper and not by heating. So basically, you can usually dry by heating or using filter paper. But نحن we prefer to use filter paper because if you heat it, it might break down the crystals into powder. Okay. For those who don't know, ionic compounds can be crystals or powder. And here, like for example, like salt. Okay, you can have crystal salt. Like I'm sure you guys have seen these types of salt before, or you can have powdered salt. Okay, this one. So yeah, over here. No, go back. This is the picture I'm trying to show you. So you can have crystals or you can have powders. If you heat it up, it might change into a powder, and we don't want that. We want it to stay as a crystal. Okay, so in the crystals in step 7 are dried using filter paper to prevent it from becoming powder. Oh, okay, we are done. Chapter 3. Thank you so much for watching. This one's 1, 2, 3, 4, 5, 6 questions. Wait. Oh no, they're long questions. We ain't doing all that. Okay, that's a different video. Thank you so much for watching and good luck.